Hello guys, welcome back to Meson African Motives. Still on Mathematics N3 in this platform. We shall be focusing on actually derivatives and also the part that we have on how to sketch some of the functions that you're given. So we're not going to waste much time. We are just going to quickly rush through the questions that we are given from the question paper of April 2020. Yeah, that's where I got these questions. Okay, let's see what we have. The first part on 5.1, we are given to draw the graph of the following equations. In the answer book, calculations need to be shown. Okay, not be shown. Okay, so which means there we do not need anything. Calculations need not be shown. Okay, all values of the points of intersection with x must be shown. So, okay, doesn't make sense, but makes sense later on. So what you're going to do is to check the type of the function that you're given or the type of the graph that you're given. Remember, you are supposed to draw this graph. So in this case, I'm going to do it as a sketch, but from this sketch, you can even tell what is happening. All right, so that was question 5.1. Let's see the equation that we are given. We are given that we have got y, which is equivalent to plus or minus the square root of 36 minus x squared. Okay. I explained in another platform that if you are given the square root of 36 minus x squared like that, they can give you a condition where it's only a plus here or a condition where you are only given a negative. For that condition, you are going to have a semicircle at the end. But if it is a plus or minus like this, this gives us a complete circle. All right, so that's a circle that you're having there. All right, let's see. If you do not understand the concept of a circle or that it is going to give you a circle, therefore, just calculate the x-intercepts, you calculate the y-intercept, then you see what is going to happen in that case. Okay, so we know that for the y-intercept, x is supposed to be equal to 0. Okay, so if x is equal to 0, let's see what is going to happen to the values of y or to the value of y. Y is equivalent to plus or minus the square root of x is equal to 0 here, so you're going to be left with the square root of 36, which we know that that will be plus or minus 6. Already we are given this as a plus or minus, so which means we are going to have our answers. We are going to have two answers, a plus and a minus. So if we are to do the same thing on the x intercepts, we know that at that moment, y is equal to 0. So if y is equal to 0, that means 0 is equal to plus or minus the square root of 36 minus x squared. But whether it's a plus or minus, the moment you divide by either sign that you're going to, either it's a plus, it's a minus, whatever that you're going to divide it, this is not going to, because that there is a 0 here. So 0 divided by any sign, it remains as a 0. So which means 0 is equal to the square root of 36 minus x squared. The plus or minus concept does not even work at all. Okay, so now we can, I mean, when you are calculating the value of x, it works when you are calculating the value of y. Okay, so if we square both sides to remove the square root, you're going to obtain 0 here, which is equal to 36 minus x squared. So you can transpose the positive, the negative 36 so that it can be a positive. That's x squared is equal to 36. So as you can see, to remove the square root, we are back again the square. You introduce the square root, which means we are back again to the square root of 36, which is the one that we calculated here, which is plus or minus 6. So we are not given a sign, which means the answer is going to carry its two possible values, a plus or a minus. So we are given a condition x being plus or minus 6, y being plus or minus 6. This is the y-intercept, these are the x-intercepts. So which means that's a complete circle because we are going to have something of this nature. Okay, let's just have it down here. So we've got our x-axis, our y-axis, and our x-axis. So this is our x-axis here, our y-axis. So if you are to take a closer look, we have got a condition where x is equal to 6 and minus 6. Y is equal to 6 or minus 6. So that one is a complete circle because it's passing through the same, the points which are the same, where x is 6 and minus 6, where y is 6 and positive 6. So it's going to give us a complete circle if we are to join these points. So we are given a condition that we are supposed to show the intercepts with x-axis, and also you can even write down the equation of the line, the equation of the circle that we are given, this which is the one that we are given before. So that was question 5.1. Then on 5.2, determine dy dx of the following function using the rules of differentiation. Leave your answer, you leave the final answer with positive exponents and insert form where applicable. Leave your answer as positive exponents and insert form. That's 5 marks for this question 5.2. Okay, so let's just rewrite our question so that we can differentiation, guys. Okay, so that was question 5.2, where we are given that y is equivalent to 1 over 2x to the exponent of 4 minus 6 over x to the exponent of negative a third plus 6a squared. Okay, let me check again. All right, that is 6ba squared. That one is a minus a third, so this is b, not 6. Okay, so we've got ba squared. Okay, so that's ba squared. So what can we do? We want to find the derivative of y with respect to x. So we are supposed to try by all means to write in this format or in this way, which you are given on differentiation on your formula sheet, the derivative of x to the exponent of n. So you must have x raised to a certain exponent like this. Okay, so that's what you're going to do in this case. We are going to rewrite. Let's start with 1 over 2x to the exponent of 4. Us here, we are going to focus with 1 over x, not the 2. The 2, we are not worried about it. So we can even write it as 1 over 2 as it is. But what about 1 over x to the exponent of? Which law or which concept actually played a role, can play a role to make this to be an exponent in terms of x? So from your laws of exponents, we understand that x to the exponent of minus a is 1 over x to the exponent of a. So what made us to write this as 1 over x to the exponent of 4 like this? It was x to the exponent of minus 4, just like x to the exponent of minus a. So this is going to be x to the exponent of minus 4. Take note, we are not differentiating so far. We are just rewriting in a way that can allow us to differentiate. We move on to negative 6 over x to the exponent of negative 1. Okay, let's start with the negative exponent there. How are we going to remove the exponent that we are given of a negative? This was supposed to be 6 over, to remove a negative, it's 1 over. There's a negative exponent, so it's 1 over x to the exponent of 1 over 3, of which, remember, I told you guys, 1 over a certain fraction is the inverse of that fraction. 1 over a over b like this is equivalent to b over a. So writing 6 divided by 1 over this simply means we've got the inverse of this number, which is 6x to the exponent of 1 over 3. If this is difficult for you to use this inverse concept, therefore divide 6 divided to 1 over x to the exponent of a third. So this is same as 6 over 1. So remember that you are dividing, you introduce the multiplication, invert the second fraction, which is going to be x to the exponent of a third over 1. So as you can see, it's the same as 6x to the exponent of a third, which is the one that we could have just used from that concept. Okay, anyways, that's what you're going to have. So this is negative 6x to the exponent of a third. Already we had a negative here, plus ba to the exponent of 2. So this is the whole expression in that manner that allows us to differentiate. So that means the derivative of y with respect to x, what are we going to have at the end here? So take note that we have this derivative, and we know that the derivative is supposed to be in this case whereby you have got x to the exponent of n, which gives us n, x to the exponent of n. So you drop the exponent, then you subtract 1 on the exponent. So that's what you're going to do. So we have got half here, x to the exponent of, so we are going to drop this exponent, which is going to be half times minus 4, which is -2. Then we subtract 1 on the exponent, like n minus 1. So this is going to be -4, -1, which is -5. So you're going to have -2x to the exponent of -5. Okay, so that's -2x to the exponent of -5. The same thing on 6. This is -6. You do the same. So it's supposed to be negative, that's a third times negative. So it's going to be like this, 6x to the exponent of a third. So this is going to drop here, a third times 6, which is 2x to the exponent of, if you subtract 1 here, that is going to be -2/3. So this will be -2/3. All right, so this is what you're going to obtain here, -2x to the exponent of -2/3 plus the derivative of BA to the exponent of, there is no x here. Take note, this is a derivative of y with respect to x, but we do not have x. It means the whole of this part, it's a constant because we do not have x. So that's a constant. And we know that the derivative of a constant is equal to 0. All right, so this is the whole derivative that you are given, but we are given a condition that this must be in terms of positive exponents and also in set form wherever it is applicable. So let's start with the negative exponents that we are given. Let these be positive exponents. So from the law, if there is a negative, it's 1 over. So this was supposed to be like this, negative 2x to the exponent of -5. It was supposed to be written as -2 times x to the exponent of -5, like that. So as you can see, this is going to be -2 times 1 over x to the exponent of 5, which is going to be -2 over x to the exponent of 5, because this is same as 1. Okay, which is the same thing that we are going to have here. The x is the one that is raised to the exponent of 2, not the 2. The 2 is going to remain on top, so it's going to be -2 over x to the exponent of 2 over 3, just like what we had here. All right, but we can see that here we can rewrite this in said form, because we're given not only as positive exponents, but also try by all means to have this written in said form. So in said form, how are we going to represent the cube, the x to the exponent of 2/3? Okay, so this is the law from your exponents that you have, x to the exponent of m over n. If we've got x to the exponent of m over n like this, it is going to give us the nth root of x to the exponent of m. So that's what you're going to have. So in this case here, we can conclude that our dy dx is going to be equivalent to -2 over x to the exponent of 5, which is already in simplest form, or -2 over, so applying this concept, x to the exponent of m over n, the n, which is the denominator here, is the one that is now in the root sign. So it is going to be the cube root of x to the exponent of m, which was the numerator, and the numerator is 2. So it is going to be x to the exponent of 2, like that. Okay, so we have written in terms of sets. In terms of sets, it simply means leave your answer under the square root. Okay. In terms of positive exponents, we can check again and again, and we'll see that our answer, the answer that we are having there, it's a positive exponent. So we do not have any problem there. All right, so that was question 5.2. Okay, let's see the other part of the question. That is on 5.3. Okay, 5.2, here we are done. Okay, so on 5.3, which is not part of 5.2, so you can remove this part. It does not affect anything now. So we are given that on 5.3, given that f of x is equivalent to x cubed minus 3x squared. And from this f of x on 5.31, make use of differentiation to find or to determine the coordinates of the turning points of the graph of f. Okay, what you're supposed to do, I think I talked about this, is that At any turning point that you shall have, the first derivative or the gradient of y with respect to x is supposed to be equal to 0. So that's the concept that you are simply working with. You already have your f of x here because we are given that our f of x is equivalent to x cubed minus 3x squared. So let's find the derivative of x here. The derivative of f with respect to x. We have to drop the exponent, subtract 1. So it's 3 times 1, which is 3, then you subtract 1. So this is going to be 3x with exponent of 3 minus 1, which is 2. You do the same thing here, you multiply 3 times 2 there. That is going to be negative 6. Then we subtract 1 on 2, which is going to be 6x to the exponent of 1, which is same as actually negative 6. So this is the first derivative that you're obtaining of the function, but we are saying that the first derivative is not just finding it, but it must be equal to 0 at any turning point. So this first derivative, when it is equal to 0, it means therefore 3x squared minus 6x is equal to 0. So let's solve for x. It's a quadratic equation, yes, but we can actually factor out some of the things. 3x is common here. So if we factor out 3x, what are you going to have? That's 3x squared divided by 3x. 3 and 3 cancel. X squared and x cancel, remain with 1x there. Minus 6 and 3, that is going to give us 2. X and x will cancel. So that's what you're going to have, equate to 0. You are going to equate to 0 until you calculate for x. All right, so from these two, from the AB concept, the 0 concept, A times B, if it is equal to 0, it means either one of these must be equal to 0. Either A is equal to 0 or B is equal to 0. So that is the concept that you're going to apply, because a bracket means you're multiplying. So it means either a condition where x is equal to 0, or we are having a condition where x minus 2 is supposed to be equal to 0. That is, each part is supposed to be equal to 0. So dividing by 3 both sides, that means x is equal to 0 here. 0 divided by n number, that's a 0 there. And on the other part, x is equivalent to 2. So take note, the question is asking us to make use of differentiation to determine the coordinates of the turning point. So to find the coordinates of the turning point, that means we have to substitute the values of x that we obtained here. So the first turning point, it's on a condition where x is equal to 0. So when x is equal to 0, what is that turning point? And the second turning point, it's on a condition where x is equal to 2. So we have to calculate the corresponding value of y in this case. Okay, I wonder why am I writing this? I have to explain. All right, so let's start with the 0 there. When x is equal to 0, we can even tell by just looking here, this is 0, this is 0 there. So which means y is going to be 0 there. Okay, when x is 2, you substitute 2 in place of x. So we've got 2 here, we've got 2 here in place of x. So that's how you actually determine this. So when x is equal to 2, y is going to be negative 4. So that's negative 4 from what we have. So we can now try to cross-check and revise as much as we can. If the answers are differing there, then let's try to work out again and again that can actually help. Okay, on 5.32, we are now given to draw the graph of the given equation, which is the one that we had before. Show all the values of the point of intersection, the axis of turning points, and this and that. Okay, that's 4 marks, so that's 5.32, or you can even write it aside here. That's 5.32. Okay, just write it aside because we need some of the information from this one. So on 5.32, in order for us to have to draw the graph, because here we are supposed to draw the graph, okay, we are given the equation, which is f of x, okay, which is equal to, let's just write this down, okay, even here, guys, we've got enough space here. So we are given that our f of x is equivalent to x cubed minus 3x. So you actually have to use the original concept that you're given. So from your f of x, which is x cubed minus 3x squared, what are we given for us to draw so far? Okay, so far we calculated the turning points, okay? If we are to check here, we calculate the TPs at 0, 0, and 2 minus 4. Okay, so we've got 0, 0, and 2 minus 4. These are the things that we have so far. It is 0, 0, and at 2 minus 4. Okay, these are the turning points. But for us to sketch, we are supposed to find even the solutions to say what are the y-intercepts. If there are y-intercepts, then the x-intercepts, what are those ones? That is what we need. So how are we going to go about this way? Okay, to find the intercept, because already the turning points are there. To find the intercepts, you are going to mention them. Remember, we've got the y-intercept first, where x is supposed to be equal to 0. All right. So when x is equal to 0, you can even tell that y is going to be equal to 0. So we have the value for the y-intercept where x is equal to 0, and at that point, we are also having the value of y, which is equal to 0. All right. So that's your y-intercept in this case where y is equal to 0. Okay, let's move on to the x-intercept. So for the x-intercept now, we must know that y is equal to 0 at that moment. So if y is equal to 0, therefore, we can at least work with x to find the value of x, because it's x cubed minus 3x squared, which is now equal to the value of y, which was a 0. Okay, so from this part, we can tell that we can see that x squared is the highest common factor that we can factor out. So if we factor out x squared, we are going to remain with x cubed. Divide by x squared, there are 2 of them. Into these 3, we are going to remain with 1x. Minus x squared and x squared will cancel. You remain with 3, and this is equal to 0. So from either one of these, our x is supposed to be equal to 0. X squared is supposed to be equal to 0, or x minus 3 is equal to 0. So here, there are 2 possible values of x that you can get. That is, it's actually like 0 twice, because there are 2 values. So it's just a 0, but there are 2 of them. Then x is equivalent to 3 on the other hand from x minus 3. All right. These are the values of x that we are having at the intercepts. But there's something that is happening now in this x-intercept. We have got a value of x here, which is equal to 0. And on the turning points, we also have the value of x, which is equal to 0. So what type of a condition is this one that we have got the value of x and the turning point? It means the turning point that we have here at 0, 0 is also a solution. So that is the concept that you have. Okay, it can be a turning point, and at the same time, it's also a solution. So having this in mind, that this is a turning point and it's also a solution, it can enable us to sketch the graph, because we know that for that type of a graph, it is going to turn at a certain moment. Then we've got something where it is going to bounce at a certain point. That's where we have this type of a function drawn. Okay, it actually bounces in the x-axis. So let's see, because we are supposed to sketch. We have the values. Okay, so everything is there. So let's just have our sketch here. All right, so we have got our x-axis and our y-axis at this moment. So let's just say this at a continuum of where we've got 0 there. So at point 0, that's a solution we are given. This is a solution. And it's also a turning point at this point here. We can 0, 0 is also given at the turning point. So that means our graph is going to turn at this point. It's going to turn at this point at point 0. But how now? We need to know the shape. So cross-checking at the shape, we can see that the coefficient, when you're having f of x is equal to x cubed minus 3x squared, the coefficient of x cubed, that's a 1, which is a positive. So we are going to have a graph that is forever positive like that. But bouncing in the x-axis, that's what you're going to have there at this 0 twice there. So we are going to have it that way. Our graph, it's going to bounce in the x-axis, and also remember the shape that you're given. So once it bounces in the x-axis at this point, definitely it is going to come down to a certain point, which is it turns back, it goes up like that, like that. Okay, so which part are we having? We are going to have 0 here, and here it's a turning point. So this 0 here, it's a turning point, yes, but it's also a solution. So that's why it is turning at this point, then it goes up like that. And this is another turning point, and we calculated the other turning point. The turning point is at 2 minus 4. That is the other turning point. So this is at 2, -4. Okay, so the values of x separated in that way. But there's no need for us to even show the values of x being separate, like 1, 2. What is important is the value of x, which is this at the solution here. Remember, when you're dealing with the solutions of this function, we had x which is equal to 0 and x which is equal to 3. So at this point, we shall have the value of x which is equal to 3. So this is the function of x that we are given to sketch. So you can actually sketch from those derivatives. They can play a major role. They can play a major role actually if you're dealing with cubic functions, but it needs us to revise as much questions as possible that can help us, and also make sure that you join the membership class so that you can have much revisions as you can, and also not forgetting to invite others as many as we can, so that we can grow as a family of Meson African motives. So that's what you had, guys, from this question. Let's continue to revise as much as we can, like I said, till we meet again.